Hello, welcome. I'm Loy Gross with the Learning Center at Genesee Community College. In this segment of Math Boot Camp, we'll understand slope. So first, what is slope? Why do we care? Well, slope is a measure of the steepness of something. Think about hiking up a hill. How steep is the hill? Does the steepness of the hill matter to you? Of course it does. But slope is so much more than hills. Let's look at a handicap ramp. Ramps for wheelchairs have a certain maximum steepness or slope so that it's easy to wheel the chair up and it doesn't run away on the way down. Notice the label on the left over here. The rise is what we call the overall height of the ramp. How far does it rise? The other measurement, the length of the ramp, is called run. And here's an odd example, but an accurate one. How fast are we going through sugar when we're making jam? Well, we can express that as a slope. On the left, we're using 1 cup of sugar for every jam jar we make. We won't go through our sugar very fast. That line has a very low slope. On the right, we're using 1.5 cups of sugar for every jar of jam that we make. We're going to go through sugar much faster. That line has a much higher slope. The steepness of that line indicates how fast we're going through the sugar and how soon we're going to need to make a trip to the store. And here's an example of slope in action, the case of an airplane taking off. First, we have the roll on the ground. That's flat, has no slope at all. And in the first segment, the airplane will begin to lift off. It has some upward slope, but not a lot. In the second segment, that slope gets higher. It's a steeper climb. In the third segment of an airplane, it's trying to accelerate, so it tends to go flat or no slope. And then in the final segment, that airplane accelerates really quickly into that sharp climb, and that's when your phone falls off the tray table and into your seat. These are all examples of slopes. Now let's look at what slope looks like on an XY plane. It's important to note that when we're measuring steepness of lines on an XY plane, we always look at the line and how it is traveling from left to right. So looking at these lines, line A has a positive upward slope going left to right, but line B, the red one, has a much steeper slope. It rises much faster. On the other hand, line C doesn't rise at all when it goes left to right, it falls. That line still has a slope. We say that it has a negative slope because it's going down. In fact, we can predict whether a line will have a positive, a negative, a zero, or an undefined slope just by looking at it. We don't even need numbers. Let's think about these green lines here as roofs on a house. In the first example, you've got a roof going up, and that line will have a positive slope. In the second example, you've got a roof going down. That line will have a negative slope. In the third example, that roof is flat. It doesn't have any slope. When we don't have any of something in math, we label that with a 0, so that roof has 0 slope. And the fourth example is not a roof at all, it's a wall. Walls aren't supposed to have slope, not usually. So we say the slope of that line is undefined. Slope is indicated by a lowercase m in all of our formulas, and it's a measure of the rise, or the distance vertically, divided by the run, or the distance horizontally. And that gives us our formula for slope. How do we measure our distance? Well, we subtract our starting point from our ending point, and the difference between the two of those is the distance between them. And that's how we get our basic slope formula. The slope is the difference between the two y values over the difference between the two matching x values. Let's try it as an actual example. To calculate an exact slope, we need any 2 points on the line, doesn't matter what two. So here we have the point 2, 1, and I've labeled that as point 1, and the point 5, 3, and I've labeled that as point 2. So now we plug those values into the formula. Where they go? Our y2, which is 3, minus our y1, which is 1, and our x2, which is 5, minus our x1, which is 2. Yes, there's a lot of numbers there, but when you're plugging them in, it's fairly simple, and the slope of that line is 2/3. And that's all it is to calculate slope.